So my goals for this session for this webinar are to explain the context of the ELIXIR rare disease pilot. So mind you, I didn't introduce myself, by the way. I'm here in the Leiden University Medical Center, and I'm the co-lead of the rare disease use case in ELIXIR, together with Ivo Gut from Barcelona, involved in RD Connect and involved in other projects, and mainly they have to do with interoperability, data interoperability in one way or another. So that was my introduction. And here I want to say that I will explain first the context of the rare disease pilot. So that is not the whole rare disease use case in ELIXIR. Maybe it's good to make that distinction. Then I will describe what a short version of a tutorial I usually give to rare disease stakeholders, to users, and I thought it would be good to share that with you here. So even if it's not something that you still need to learn, then you at least know what we tell other people. And then I will give an intermediate update of the pilot, and I should also mention here that the pilot is halfway, so there's no finished products yet for the pilot, so it's an intermediate update. So maybe also to give what I was saying is that my expectation for the webinar, that's why the introductions are good, is to get participants who are in ELIXIR one way or another, and particularly the interoperability platform, and people from the rare disease community in various projects, that they would come to this webinar. But yeah, hopefully, maybe in the discussion I'll find out that other people also with completely different backgrounds joined today. So, the context of the rare disease pilot. So first, from the perspective of the rare diseases. So for those who are not in the rare disease field, obviously rare diseases are rare. There are sometimes some criticism that rare diseases are diseases, and of course that is true, but there are some specific characteristics which make that the rare disease community often comes together and makes a strong point of joining forces. One thing is that it's costly for drug development. There's of course a low frequency of cases and samples in the world. And on the other hand, there's many access points and many sub-communities. There are huge amounts of rare diseases. So that also means that data is often scattered. And there's a big push from rare disease patients who know all these facts and push the researchers and the clinicians to combine their strengths and to combine data where possible. And this push also has been heard by the Rare Disease Research Consortium, RDRC, and they have set an ambitious goal to have at least 200 more treatments by 2020. So this is always something that's in the back of our mind when we work on rare diseases. So what are the needs? I guess you can have a longer list, but these are the needs I've listed here. So sharing rare disease data, and that can be all sorts of data, from population to species to genetics, etc., etc. And it's also data from rare diseases, but also data for rare diseases that might be from a different origin, but still relevant for the study of rare diseases. And there's sharing the state-of-the-art bioinformatics tools and facilitated data integration. So I think roughly 3 years ago, the RD Connect project was started with the ambition to be and to build a platform for the rare disease research community. And it was supported in a way by two major omics projects that provide for whom RD Connect is the platform for their data. But it also combines other types of data. It's really for connecting all different types of information and tools. And it's also a good source of use cases. As for the computer science side of things and for the engineering side of things, it's a rich source of people who have really use cases. And as you can see on the right, some people have clever critical ideas of problems that might arise. So then the other perspective, the context from ELIXIR and the fair data perspective. So ELIXIR is this, for those who are not so involved in ELIXIR, is a pan-European infrastructure, bioinformatics infrastructure project with the subtext Data for Life, which different infrastructure sort of components to it for data, standards, tools, compute training and industry. And some people on this call can say more about it than I do, I guess. And in it recently got a grant to really set things up and build platforms, and you see them at the bottom. The tools platform, a data platform, compute interoperability, and there's training and capacity building. And they defined a couple of use cases that drive the infrastructure development in ELIXIR, and the rare diseases is one of them. And the pilot that I'm talking about is especially the combination of the rare disease use case and the interoperability. And then the fair data principles. These we've been working for a while, and it's really a set of principles of that data should be findable, accessible, interoperable, and reusable, both for humans and for machines. And again, the pilot has a specific focus in this. So when I would put that graphically like this, then the interoperability is the main part, because it is about enabling questions and analysis across rare disease resources. But it also relates to the other points, but this is in the order of priority, so to say, for the pilot. And I would like to mention that if you want to know more about this, about FAIR, the principles, and especially ideas of how to implement FAIR principles, then I would refer you to the webinar that Louis Bonino gave previously, and you can find them on the ELIXIR website. So then I would like to give you a view of the tutorial that we give to, so to say, newbies when we implement the interoperability part of FAIR by linked data and ontologies, by this technology. So usually when we do a bring your own data meeting, I start with these slides, a slightly longer version of this. And here I wanted to share that with you. So this is the first slide. So it's about linked data and ontologies. And I use a case, an interview I did with Ulrike. Some of you on this call know this story now very well, because I did this many times. And my case study is by Ulrike. It's a clinical researcher in Germany, and she works on CAG repeat length diseases such as Huntington's disease. And she would like to combine a number of population studies, information from these population studies, for her research question about CAG repeat length. And then that's good, she has three different sources that she can use, one from the US and two from Europe. But she finds when she wants to combine this, that in some cases it's okay, in other cases she finds the situation that she gave me here is that it seems very similar, all these types of data, but when you look more carefully, you see there's actually discrepancies between them. They're not exactly the same. And then you might ask how she would solve this. And the typical way that this is solved is that Ulrike solves the problem herself. So she has these three different data sources, and then she has to do the heavy lifting of combining those into one of her own registries. And I get a comment from Claudio. I hope he's the only one. But can anyone else hear me? Maybe put it on the chat.
We can hear you perfectly.
Yes, I can hear you.
Sounds fine here.
Okay, then I'll continue. Then hopefully Claudio can solve it on his side. So yeah, I was saying, so Ulrike has to do the heavy lifting for putting the data together in the right way. So she has to find out somehow how these data that should be very similar, how they relate to each other, to answer a research question. Now, if this was only Ulrike who had this problem, then maybe that would be okay. But this is very valuable data, and usually data is valuable. So there are many more people who would like to use this data. So it's not just Ulrike. And there could be also people who want to combine this data with other types of data, etc., etc. So basically, all these people have to go through this process. They all do this heavy lifting. So this is very, very inefficient. And if you remember this ambition to go for 200 more treatments, then this type of slowing down the whole process is not desirable. And the other thing is that computers cannot help. So the data is put into databases, but that doesn't mean that it really resolves the problem I just described for Ulrike. So computers cannot really help Ulrike. So another way of putting this is that I make this graph for the distribution of the pain of data integration. So this is all in the context of data integration. So of course, when you want to do that, there's of course the experiment itself that produces the data, and then the data integration analysis, etc. So the pain distribution there is that, of course, there's pain that goes into the experiment. There's not so much we can do about that, at least not from a bioinformatics point of view. And there's actually, in the context of data integration, there's not so much pain in terms of the data generation. So typically people put it from their perspective into their database as long as they understand it. So that means that the pain for data integration, as I just described, is really with the Ulrikes of this world. And it's also multiplied. So it's pain for many people. And as I mentioned, computers cannot really help. So basically what we want to do with these technologies is not remove the pain, but move the pain and make this whole process a bit more efficient. So we want to move the pain upwards, closer to the data generation, where the actual experts of the data are, the experts of what the data means are, so that the data integration itself, the combining of data, gets easier for Ulrike and people like Ulrike. And the other ambition is that we make it so that computers can help us a little bit. So to go to that step, the first thing I typically do is to disentangle the term harmonization, which is, especially I've learned this for the first time in the biobanking world, when data is not so easy to combine. But I would like to pull that apart into 3 layers. And the first is harmonize what is measured and how. The second is to harmonize the classification, the meaning of the data. And the third is to harmonize how we make it computable. So these 3 levels. And there are methods for this. So the first one for what is measured and how, that's good old-fashioned reaching consensus in communities. That doesn't go away with the technologies. And there's the harmonization of the classification. That's where the ontologies come in. And finally, at the bottom is the linked data. That is the technology of making it computable. And ontologies have a nice place in the middle of this because they stimulate reaching consensus. If you agree on which concept you will use, you probably have discussions about what you're going to measure anyway. So it has some influence there. But ontologies are also can also be made computer readable themselves in the same lingo as linked data. So they're completely they can be very easily combined. And then for the computer people maybe on this call, we often get the questions: how does this all perform? Well, the whole linked data technology and interoperability, the primary aim is not high performance computing. If that is what you require, then you can always transform the data again into something that is applicable for high performance computing. So that's you could say that that's the 4th layer in this graph. Okay, so coming back to Ulrike. something that I often see, and it is good, is that people add ontology terms into their tables, which is perfectly fine and a good step in the right direction. But it's not this. We've not reached this full linked data computability yet, because for a computer this still is just some term in a table in a column with some header that it doesn't really understand. So it doesn't make it really understandable for computers yet. Actually, to go that way, you have something that is a bit more like this, what we call uniform resource identifiers that are readable for computers and maybe not so readable for us anymore as human beings. But that's what makes it computer readable then. So looking at that again, the uniform resource identifier, that's really the key element of linked data, as we call it, or data linkage. And the cool thing about that is that it has it's three things at once. It's a unique identifier for a data item or concept, but it's also a unique reference to the data item, and it is computer readable. And we know it from the form that you just saw. We know that from the World Wide Web, and just a reuse of technology. But then instead of what you see here for linking documents, hyperlinks for documents for, in the end, human beings to read, we use it for linking data, and that is then for computer consumption. And the other thing is that part of the definition is that you can make statements with these URIs by putting three together. So that's a subject, predicate, object combination, this triple, and with that you can say things. So you can, for instance, make real biological statements. Here, HDAC interacts with PAR-VB, by the way, which is not true, just here an example. Or you could say that HDAC1 is of type protein, and protein would then be from an ontology, so that's where the ontologies, the link with the ontologies come in. Or HDAC1 is the same as a synonym for HDAC1 here, and so that shows how you can do mappings with these triples. And there's whole vocabularies for these. Instead of same as, you can have more subtle things there in the middle. And here I've shown between these brackets a sort of human readable version of these URIs, but they are real URIs. So if you look at this one statement, for the non-human readable version would look something like this. So that's the equivalent of that, but then in URI computer readable form. So finally coming back to Ulrike then again. So that means that when she's confronted with a problem like this, with the three sources, if these sources, so here where she had to do the heavy lifting, remember, whether it was painful to do this combination, if there would be a fair or linkable version of this data as well, if the sources would have provided that, remember putting the pain to the data generation, if they would have provided that, then it would have been maybe not trivial, but it would have been a lot easier for Ulrike to combine this data. If you really do it to perfection, then it's really trivial to put the data together and make the right connections and the right questions. So in conclusion, with this technology, you prepare data for data linkage, for combining data. It makes it much easier, and therefore it shortens one step towards new treatments for many researchers, and that's what we're after for this ambitious goal for the rare disease. So that brings me to the actual use case and pilot. And maybe I should also mention, if you have questions, then please write them down and we come back to that after the presentation. So I should state here, we defined within first in RD Connect, we defined a use case which is somewhat bigger than the pilot. So the pilot addresses one part of the use case. So for the use case, we defined a process more or less like this, that we need to select a user question to drive the whole process, to drive the development towards making data linkable and showing how that works. And then, of course, we need to fill the user question in with actual data. So selecting that from the community of rare disease researchers, refine the user questions where needed, and then go through a development cycle with a multi-project task force, because no single project can do that on its own with the current capacity that we have. And then the outcome is that we answer, of course, the user question, that we get some resources in a more linkable format, in a fair format, and that we have some standard procedures of how to get there. And of course, documented processes, etc. Now, for the ELIXIR pilot, so this is more the general case. For the ELIXIR pilot, we're really focusing, the outcome is slightly more modest. So we're aiming for recommendations, because this is to give us a starting point, both for the collaboration between several projects, and especially also the collaboration between the rare disease use case and the interoperability platform within ELIXIR, is to have design recommendations, to have recommendations for the procedures of how to make data interoperable at the source, and to demonstrate how these technologies enable answering questions across resources. And here, I guess it was large enough, so you just saw that in the previous slide. So in practice, because we have started doing this with the pilot, so in practice, we already had some interesting observations. So one is that the first part of the process, the defining the user question, it actually takes some iterations to get there, to really understand each other, to get the right data for the proof of concept, etc., etc. So that actually takes a bit more time than maybe we had anticipated, although I'm not entirely surprised. And how we work is until now through bring your own data meetings and hackathons that have been very successful. Then maybe we can discuss after the talk how we can get the software engineering also in other ways, but this has been how we did it thus far. So this is then the things we've done so far. In gray are the ones that actually predate the starting point of the ELIXIR pilot, but they led up to the ELIXIR pilot. So we had already the end of 2014, we had a bring your own data meeting, and I have to praise the people in Italy. We had several in Rome, so they organized everything at the ISS. And at the end of the talk, the Italians on this call can give the real Italian name of that institute, but I don't dare to speak Italian here. So we have had the first bring your own data meeting for combining registries and biobanks. And then later on, we had an RDConnect annual meeting. And then we really started the pilot, did a bring your own data, a second bring your own data meeting combined with a hackathon. And where we are now is that we are continuing on the results of those meetings. And we also did a tutorial recently in Rome. And I would like to point out that at the end of the year, that November 30, we start a course, and I would like everyone who is interested in these technologies to register for that course. So participants of these events are usually representatives of registries and biobanks, and some key resources such as people from Orphanet, and data linkage experts and rare disease platform designers. So a bit more detail then. For the first BYOD, it was sort of a beginner's training. We had people from, there was a combination made between the tool ID card, which is a registry of registries and biobanks, and Orphanet. There were some mock data conversions, and we identified bottlenecks, like the standard data conversion procedure is hard, the finding ontologies and identifiers was a bottleneck, and the access restrictions. And this led to, was actually the input for the ELIXIR pilot. So then the next step was the annual meeting from RDConnect, and there we defined altogether in a poll, we defined what the template use case should be to drive this interoperability case. And I've highlighted some people here, and I could highlight some more, but these are key people to help refine and fill in the blanks in in this user question, so they are our contact point for the larger community, and they have the context there. So then there was the second BYOD-N hackathon, and this is really overwhelmingly successful, I would say. In 3 days, 2 days BYOD, 1 day hackathon, we had over 40 to-dos after that, and we worked on lots of things. User scenarios, we had feedback on ID card, I mentioned it before, and we had work on common data elements, which is really at the consensus level of what people are working on in this field. There were questions, and we discussed patient identifiers, common APIs, accessor services, which is sort of an implementation of that. We made a glossary. We started making a glossary of terms because with all these different disciplines, you have to start doing that. We worked on a procedure for making data interoperable, so that's the first step towards a recommended procedure. And there was a new case for sort of identifying, making the model for how data elements in different resources in the platform, how they connect. And there was also some new cases, so we have some more data to work on. So follow-up, that's where we are now. Working on these data accessors that were going on within the FAIR data developers, and we're now participating in that. There's an analysis going on of the standard operating procedures for the data conversion. There's a reference model for these data element identifiers now that we can continue on. As a proof of concept for the data conversion and integration is also in progress. So both with the tool CoUse and with scripts, and recently also we're looking at Google Refine. And yeah, we have had some data now to work with, and there's the tutorial material that we create. And again, I ask attention for the course. So just to give you an idea, this is the data accessor. This is actually the first prototype was made by Mark Wilkinson. And that is one way of dealing with the access restrictions without doing any specific technology for authentication and these kind of things. That's beyond the scope of the pilot. But it is a way via REST calls to just allow the data source to give what it wants to give. So we do it stepwise. If you start at the bottom, in the first instance, you get sort of the shallow metadata that you can usually always get. And if the accessor allows it, you can go deeper and deeper into the data until you get the actual data, if it allows it. And this is a schema preliminary of how it is related to the semantic reference model that we made for these different sources and the identifiers that are used there. And it's still preliminary, so this might change. But you see at the bottom these different sources. The semantic model would be used as a reference. And Rajam in our group, for instance, is working on this linked data cache to put some of the use case data in there to show the principle of how you can then do questions across resources. And on the right, you see the mapping story. And we haven't really touched on that yet. But that might come because it's very clear also from the tutorial that we recently gave that mapping is a clear issue. And what is also interesting is that actually a lot of people are doing the mappings, but they don't know that they are doing the mappings. They, for instance, give two different ontology terms for something and don't realize that by doing that you actually created a mapping. So this is then the timeline. So we started with proof of concept, testing the platform, and we aim to end the pilot at the next RD Connect plenary meeting. That's a nice goal. It's in March. So then we should be ready to give the recommendations, and our ambition is to also show a demonstrator there. And then in the next years, we can follow this up by working it out beyond a pilot. So some challenges. There's provision of data for the proof of concept. That is, I've seen that in all the projects I've been in. that's often something that is a sort of a communication problems that you have to overcome, and it takes time. That's the thing. Then access to the builders of patient registries, especially on the patient registry side, that turned out to be something specific that we often talk to the managers of the data managers and not the data managers themselves, which also led to give recommendations for this group and to define that as well. So that was also something new as an outcome of the pilot. And then we need to do capacity building, as I mentioned, for development work that needs to be done. We need to collaborate between projects, and of course that's a challenge, and especially, for instance, for the alignment of the different timelines. And of course, not listed are the bottlenecks that we are addressing in the pilot of what the pilot is for. So I end with a summary, a very symbolic summary. So what is the pilot about? It's about researchers for whom we want to make it easier to combine data for their research. So it's about data, such as patient data, and you have different sources of patient data, sample data, biological samples, and also there you can have different sources of that. Omics data, also there you can have different sources. Biological knowledge, and how when you look at just the data, it might be difficult to combine them. So the pilot is about data and is about making that data machine readable and linkable. And I have to remind here that this is still data, but just in a machine readable and linkable form, but it is still data. And that makes it all easier to combine data. That's the vision we work with here. And of course, around that are also tools and bioinformatics services. So in the larger use case, there's some building going on there for the ELIXIR pilot, for the pilot itself. It's about testing the procedures for getting from the data to the machine readable linkable data, and for the basic tools and services for applications of this type of data. So we're aiming for standard operating procedures, reference design, and ultimately we hope to demonstrate this next year. So that was my presentation, and thank you very much for your attention.